Alright, for this video, we're going to just go over number 13 on the back side of the worksheet. Now we're going to make these problems a lot harder. We're going to have two shifts. A horizontal shift, which you can see, you have that 4x plus pi in parentheses, so we should shift this to the left. But now we also have this vertical shifted too. Now here's the main thing. I already have this on here for you. When you have an equation, the vertical shift always equals the equilibrium. Remember, that's the middle point of the sine or cosine wave. So since this vertical shift is a positive 2, you're going up 2. Normally the equilibrium's at 0, then it moves up 2 units. So we're going to get the y values first. The equilibrium is 2. Now there's two things that affect the y values. The vertical shift and also the amplitude. The amplitude here is clear to see, that's 1/2. So to get the max, you just add the amplitude to the equilibrium. So if I add 1/2 to this 2, that tells me the max is 2.5. To get the minimum, well then I subtract the amplitude from the equilibrium. So 2 minus 1/2 is 1.5. So it's a very short wave that we're going to look at. So these are the only y values that we're going to get. And there's really not a whole lot of math to do to that. You look to see what the vertical shift is, you apply the amplitude to it, and you know what the y values are going to be. All right, it's always harder getting the x values. Okay, let's go through the whole setup here. The period's 2 pi over b. b is this 4. So 2 pi over 4, that reduces to 1/2 a pi, or pi over 2. So that's the period. Now, I said this is going to be a horizontal shift. We're going to shift this to the left. To get the starting point, we take what's in parentheses. In this case, it's 4x plus pi, and we set it equal to 0. Well, if we set this equal to 0, we would subtract pi from both sides. We would have 4x equals negative pi. Then we would divide by 4. So I'll put here, this is the starting x value. I divide by 4, and x equals negative pi over 4. That makes sense. We're starting at a negative because I shift to the left of the origin. Now the end, I take the same thing in parentheses, 4x plus pi. Now I set it equal to the normal ending point for one revolution, which is 2 pi. Then if I subtract pi from both sides, okay, we're going to get 4x equals, see here, this 2 pi minus this pi is pi. Divide by 4, and it ends at x equals pi over 4. So this is where I start here at negative pi over 4. This is where I end at pi over 4. Okay, I get the increments. I take the period, and I divide it. Period's 2. I divide it by 4. That's the same as multiplying it by 1/4. So when I multiply across, this is pi over 8. So it just gets a little ugly with these fractions. That's the hardest part, dealing with the fractions and the algebra of it. Okay, key points. I know I start with this, negative pi over 4. Then I add the increments to it. So to get the next x value, I'm going to add pi over 8 to it. Now, I'll write this right underneath negative pi over 4. This is the same as saying negative 2 pi over 8. It's the same thing as negative pi over 4. If I add pi over 8 to this, I get negative pi over 8. And then if I add pi over 8 to negative pi over 8, it's 0. Now this part's easy. If I add pi over 8 to 0, I get pi over 8. And if I add pi over 8 to this pi over 8, I get 2 pi over 8. And that reduces to pi over 4. Right, this is my fifth x value. Look, it matches up with the ending point, so I know I'm good to go here. Y value should be real easy to get. Sine, remember we always start here with the equilibrium, so the first y value is going to be 2. Since this is positive 1/2, that means I go up to the max next. So the next x value, or the next y value is going to be 2.5. So we'll say 2.5. Then we have to come back down to the equilibrium of 2. We go down to the minimum of 1.5. And then we end at where we started, the equilibrium of 2. So that's the hard part right there. Let's take this, let's graph it. Okay, alright, looks good right there. Okay, so we're going, let's see here. I'll make this negative pi over 4. This is negative pi over 8. We have 0. This is pi over 8. All right, make sure just to label it. This is pi over 4. And we're good to go. So let's graph it. Negative pi over 4, we're at 2. This is the equilibrium. Whoops, actually, you know what? Let's get rid of that point. because I want to put it actually right here. This is negative pi over 4. All right, negative pi over 4, we're at 2. Negative pi over 8, we're at the max 2.5, which is right here. 0, we're at 2. So it's a very, very short wave, you can see. Pi over 8, we're at 1.5, which is right here. And pi over 4, we end at the equilibrium. So not a very tall wave at all. So we connect it, it just goes up. That's what it looks like right there. So it's always the same shape. But this, we had a lot going on. We had a horizontal shift. We shifted it to the left. And we had a vertical shift, bringing it up at 2. So if I actually draw this dotted line right at 2, it's tough to see right there. That's at the middle part of the wave, which equaled the vertical shift.